Let's see, this should go to full screen. Whoops. What's going on here? Cool. Okay, I hope this is, can everybody see?
Yes.
All right, cool. Right, yeah, as was anticipated, I'm starting off with an intro slide. I am Michael. I'm a coder living in what we call the other Vancouver, which is to say Vancouver, Washington. If you're not familiar, that's just across the Columbia River from Portland, Oregon. Here's my contact information. You can find me on GitHub. I have a website, Unwound Stack, where I write about various aspects of coding. So tonight I'm going to be presenting a personal project, a Rust project that I call indielinks. And my elevator pitch is that indielinks is social bookmarking in the Fediverse. Of course, that means you need to understand what is meant by social bookmarking and what the Fediverse is. So let me speak to that very quickly before we get to the project itself. So social bookmarking was pioneered by Delicious. This is a screenshot from 2008 via the Wayback Machine. Yeah, I think it's fair to call it one of the first social networking sites. You could sign up, you could save your bookmarks there, and organize them, and just use Delicious as a bookmarking service if that's all you really wanted to do. But you could connect with other people on Delicious and see what they were bookmarking and talk about it. As you can see in the screenshot, they have leaderboards of various kinds, most popular bookmarks today, this week, this month, etc., popular tags, as you can see. Very quick overview. It was founded in 2003. Yahoo acquired them in 2005. By the end of 2008, they claimed over 5 million users, which I think was pretty good numbers at that time. But what I really want to emphasize is that by making bookmarking social, by sort of creating these leaderboards, by letting you follow people that you found interesting, the site really became more than just a bookmark organization service, and sort of became a content discovery mechanism. People at the time would talk about what was trending on Delicious. Yahoo made some missteps. I think there was a memo that leaked in 2010 that seemed to indicate that Yahoo was planning to shutter the site. That led to a mass exodus. It passed through the hands of a few other buyers over the course of the teens, and was eventually shut down in 2017, if memory serves. Yeah, that's what I mean by social bookmarking. Now, the Fediverse is an ecosystem of federated social networking services, all driven by ActivityPub, which is a protocol. Just jumping over to my speaker notes here. The one you are most likely to have heard of is Mastodon, which is a microblogging site along the lines of like X or Blue Sky. But it differs in that there's no central site. If you want to join Mastodon, there's no mastodon.com that you sign up at. Your first step is going to be identifying a particular instance of Mastodon that you would like to join. Instances often grow up around a shared interest or topic. For instance, I'm on indieweb.social. They also can be location-based. I'm pretty sure there's a Vancouver Mastodon instance. I know there's a Portland one and an SF Bay Area instance. But once you've joined, you're free to follow and respond to and generally interact with anybody on Mastodon so long as your instance is federated with their instance. And if you come to find that your instance no longer suits you, you're free to take your identity and your followers to a different instance. So there've been a lot of services built on ActivityPub. We've got Mastodon and Pleroma for microblogging. Lemmy is like a federated Reddit. PixelFed is sort of an Instagram clone, and many others. Something that I think doesn't really get enough attention is that on ActivityPub, not only can different instances of a given service federate, but instances of different services can federate. So, for instance, I've followed people on PixelFed from my Mastodon account, and when they post, I see a little entry in my timeline, and when I comment or like, that shows up on their PixelFed page. And so it's this kind of slightly chaotic ecosystem that we today call the Fediverse. And so when I say indielinks is social bookmarking on the Fediverse, and this is a screenshot of indielinks, you know, like Delicious, you can save your bookmarks to it and tag them. This is my hacking reading list as it appeared a couple days ago. But you can also follow other people, see what they're bookmarking, discuss, and you can federate with other social networking services that speak ActivityPub. And I have it, despite my better judgment, I have a demo. Let's see here. So let's bring this, do this. Bring this front and center. Let me kind of explain the situation here. So what you're looking at in the center is indielinks. I have an instance running locally on my development machine. This is the front end. If we hop over here, this is the log output of the indielinks process. And then what I've done is I own a domain name, independent.net, that I brought to Cloudflare, and I set up a Cloudflare tunnel that connects that domain name to my local indielinks instance here. If we look up here, this is a little agent, Cloudflare, that reaches out to their name servers and sort of proxies the traffic over to my indielinks instance. So if we look here, I can curl independent.net/health check, and as you can see, I get an HTTP 200. Good. And if we jump down here, yeah, here's the log statements for that incoming request and the response. Okay. So and this is Mastodon. I'm on my my Mastodon instance, which is indieweb.social. And as you can see, I'm following spiff at independ.net. So if I add a link here, let's say, unread, I've just updated this link. But if I go to my home timeline. Oh, I would have expected it to show up. Let's see. Now let's go search. Okay, well, no, this was actually from earlier today. Okay, so my demo kind of let me down. I wonder what happened. There's a lot of traffic here. Oh, interesting.
Live demoing.
Yeah, that's interesting. Yeah, it looks like there was some sort of authentication failure somewhere. Let's wonder if it. No, let's try it again. Maybe if I can say a different link. Oops. Looks better. Oh, hey, here we go. So it shows up on Mastodon. My front end is very incomplete, but you'll see that if I like this, some traffic goes running through my my service. If I go here, you can see we just got the like coming in. Yeah, so that's kind of the demo. Now, this is a Rust meetup, so I don't think any of you came here to hear about the Fediverse or social bookmarking. So I just picked a few topics, lessons learned from the project so far that I thought I'd briefly speak to. The first is why Rust. I know some of you are not working in Rust professionally and would like to be. Maybe I can give you a little bit of ammo the next time you want to argue for using Rust in a project. But I got to be honest. The foremost reason was social, not technical. I hope to entice others to contribute to indielinks, and among the languages I enjoy working in, Rust is far and away the most popular. But there are some technical reasons. I think one can effectively argue for Rust as a web service. In the Haskell community, there's an aphorism: parse, don't validate. And what they mean by that is this is a call to parse your input into application-specific types as close to the program boundary as you can. And there are a couple of advantages to this. The first is if the input doesn't parse, you're generally well positioned to just drop the request and return an error code of some kind. You're not 40 frames deep in this massive stack, and you don't need to undo half of what you've done to serve the request. The other and bigger benefit is if your type system is expressive enough, you can dispense with what in my days coding C in the 90s we called defensive coding. Right? This was the belief that you should preface all of your functions with all kinds of asserts, checking that the input actually satisfies your preconditions. In a language like Haskell, your types are expressive enough that those preconditions can be expressed in types. And so in your downstream functions, like the fact that the caller has an instance of their input types is a form of a correctness proof. And they can simply move forward with their work without all sorts of tedious assertions. And yeah, Rust type system is not Haskell, but it's pretty good. And certainly, if you look at the landscape of languages in widespread use in industry, Rust certainly has one of the most expressive out there. And so that enabled me to parse instead of validate my input in indielinks. And then another argument for Rust that I think doesn't really get enough attention is operational ease. I've spent time in my career as an SRE, and I can attest that a memory-safe language with no runtime is a very compelling proposition. Certainly, in comparison to needier or languages that are needier of SRE attention, like say Python or Java. So, kind of another little interesting learning relates to the web framework I used. Axum is an async web framework that's very popular in the Rust community. I used it for indielinks. And as is typical with these sorts of things, the way you structure an Axum web server is somewhere pretty close to main. You end up writing code like this, where you set up routes and handlers. What was interesting to me about Axum, and has always been interesting to me about is that you can throw almost anything at it in terms of a handler, and it seems to figure it out, and it all type checks. So, for example, these are all legitimate handlers. And if you look at the third and the fourth examples, they use what Axum calls extractors. So Axum and some related crates built on top of Axum define a suite of what they call extractors. An extractor will extract some portion, some aspect of the incoming request for your use in your handler. So in post-foo, I'm using the query extractor, and so Axum will, when post-foo is invoked, Axum will populate the parameter with the query parameters of the request expressed through the hash. In foo bar, you see I'm going to get a replacement parameter from the past. If we look up here, foo bar has this sort of interesting little syntax. And it'll also give me the full header map, and it also demonstrates that I can also say, look, damn it, just give me the raw request. Never understood how all of these could possibly type check, and so one afternoon this spring, I just kind of started reading code, and found this little bit of magic. If you recall, when we were setting up our routes, we didn't just say path function. We indicated the HTTP verb with these little helper functions, get, put, post, and so on. If you look at, if we just focus in on get, you see its parameter is generic. It takes a thing so long as that thing implements the handler trait, which they then turn around and provide so-called blanket implementations for any type f, where f is a function of no parameters and returns this intimidating looking type, or it's a function of one parameter, and that parameter can be anything so long as it implements from request, which is another Axum defined trait, or any function of two generic parameters, where the first one implements from request parts and the second from request. And actually, they just keep going. They'll let you define any function of up to 16 parameters. so long as the first n-1 parameters implement from request parts and the last one implements from request. Now the blanket implementation itself is a little messy, involves some macro magic, and it doesn't really lend itself well to a brief presentation like this. But even still, I thought this was kind of a real tour de force of what the Rust crate system can do. And then my sort of last kind of lesson learned came from actually having to test this thing. I discovered pretty quickly that Cargo's test facilities are really about testing library crates. Yes, they have a facility that they call integration testing, but the assumption is still that your test is invoking a library crate. The so-called integration tests are only distinguished from unit tests by not having privileged access to the code under test. So this is not great if, say, you would like to test a web service. It's not great if your test requires you to spin up a database that backs the web service and maybe charge that database with some test data, and then tear it down, of course, when the test is done. So there's an escape hatch. If we put this incantation in our cargo.toml, Cargo will interpret this to mean we want out of the default test ranks, and it will expect a file in our integration test directory called integration.rs. It expects there to be a main in that file. And after that, you're on your own. If your tests run successfully, you must exit with status 0. And if they do not run successfully, you must exit with status 1. That's it. According to the docs, there are no other expectations of your integration test. It's not a great extension point in the sense that it's too wide if you take money in. Yes, we can change out the things that we need to change out, but we also have to handle a bunch of stuff that we're not interested in customizing, specifically or in particular command line arguments. If you say cargo test help, you will see that each integration test can receive any number of command line arguments after the dash in the invocation. According to the docs, a compliant implementation is free to simply ignore all those command line arguments, but that seems like a suboptimal developer experience. We can parse them ourselves, but I counted 16 different command line arguments in the docs. That seemed like a lot of work when I didn't even really want to do anything differently than the default harness. So somebody else must have encountered this because there's a crate called libtest mimic. And really what it does is it handles everything that I really didn't want to bother customizing. So once you add libtest mimic to your dev dependencies, you can at least get to this, that the library will handle argument parsing. It will run your tests while trying to replicate Cargo's style of output, and it will handle compliant exit status as well. The trick is, how do you express your tests to the library? And that's what I've stubbed out in this little code snippet with the to-do macro. What we need to give it is a vec of trial, where a trial is defined by the library. And we can construct trial instances pretty simply. We'll provide a constructor You need to give it a textual name and something that looks like a function that takes no parameters. It returns a result. So it would have been pretty easy to just write my tests where the tests would sort of spin up the database, charge the database, spin up the web service, point a client at it, and test in terms of request and response. And then sort of in my, in main, just have a static list. Just use the vec macro to construct it. But I didn't want to do that. I'm always forgetting to keep things like that up to date. And if you forget to keep it up to date, there's no error, right? The thing will happily run and report that all tests passed and not give you any indication that you forgot to add, the 3 tests you just wrote to it. So I found a crate by David Tolnay of Cerda fame called Inventory. And what you can do is you can set up a global registry where you can register items from anywhere. So what I did was I created a type, imaginatively named test. As 2 members, a name and a function. And then I used the inventory macro collect to tell the crate that I was going to be registering instances of this type from around my project. So now I was able to code in the way I wanted to, right? I write my cool test, and then right then and there, before I can forget, I register it with the inventory. And then back in main, the inventory iter function give you an iterator or a thing that implements into iter over all the instances of tests that you've registered anywhere in your program. And it's a trivial call to map and collect to convert it to a vec trial for libtest mimic. So I finally wound up with something like this, where the web service went into one crate and the integration tests for the web service went into a second crate. Yeah. So in terms of project status, WYSI demo aside, it's definitely a work in progress. I kind of volunteered to present at this meetup as sort of a forcing function to get me to buckle down. Next steps, I'd like to put together a Debian and an Arch package. It's available on GitHub. I've published it today. I'd like to put together Debian and Arch packages so people can at least install it locally and play with it. Front end is very incomplete and looks like it was written by a back end developer. And then, at some point I'm going to stand up a beta instance publicly. That's it.
All right. Thank you for the presentation.
Any questions? Just yell or reach out.
I actually appreciated the shallow dive into Axiom. It's a lot closer to Actix Web than I expected. I hadn't actually used Axiom in Anger, so I kind of have a big familiarity with it because Shuttle, they've done a challenges thing, kind of like Advent of Code, but not Advent of Code. Their version of it, a simplified version where they use things that build web servers. And usually they have instructions for Axiom, for Actix Web, and something else I can't remember. And I would look at the Axiom ones from time to time, and I would say, okay, that's kind of similar to the Actix Web ones. But it's one thing to kind of see a couple examples. It's another thing to see, oh, it's literally defined this way. I appreciated that. That was pretty great for me.
Yeah, it's always tough. I mean, when you're trying to choose among frameworks, you can read the docs as long as you want, but until you've really used them in anger, you don't really know which
Right.
one you want.
I think Axum is the fastest growing one, in my opinion, at least, based on what I've
Interesting.
seen.
Yeah.
The reason I'm still with Actix Web is because that's what the book was written for. Luca Palmieri wrote a book. Yeah, exactly. Zero to Production in Rust. And I just loved that book. That was because when I started my project, I decided to make bad decisions and just do everything from scratch. When I say everything, I mean, like just kind of almost from scratch. And so I started Googling like the security aspects and all. I kept Googling, the different parts as you're going Googling parts. And every time I would get an exit from the book. And I was like, wait, you mean everything I'm looking for is in this book? Why didn't I just get the book? It was the best purchase I made in my life. It was really great.
All right, maybe I'll make a note of that.
I mean,
I think the book is worth a read.
What's it called? Production Rust?
Zero to Production in Rust.
Zero to Production. Oh, I know it. I know it. All right.
And it also covers testing. The approach used for testing in the book, I would argue, is probably a little simpler than what you do. Essentially, the spin up code, he put it into a function and he just calls the function at the beginning of each of his tests.
Mhm.
And
Oh,
that,
yep. Yeah, I considered that. I wanted to. So indielinks can be run in a number of different configurations. It can even be backed by different data stores. And so what I wanted a very crisp separation between testing logic and fixture setup and teardown, because I want to run the same test against many different fixtures.
gotcha.
Yeah, that's why I did not take precisely that approach, which I was aware of.
Right. Yeah. That's how do you switch between them? Between your different backings?
Config, and
Config.
then so lessons learned. I wrote myself an object safe trait that expressed all the storage operations that I needed to carry out. And then pretty early in the service startup, it reads config and says, oh, okay, you want to run against ScyllaDB. Let me instantiate the ScyllaDB implementation of that trait. Or, oh, you want to run against DynamoDB. Let me instantiate my DynamoDB implementation of that trait. Very 90s object-oriented approach. Considering ripping it all out, to be honest. ScyllaDB, it's a wide column NoSQL data store, very much like Cassandra or DynamoDB. They've rolled out a new interface that is compatible with DynamoDB. So like over here, if you can see it, I'm running the AWS CLI against a local ScyllaDB instance, right? So it would really simplify the code quite a bit if I just said, the hell with it, I'll talk to any data store that speaks DynamoDB.
Right.
And just vote the one implementation.
Right. And then you can probably even have different implementations of Dynamo interfaces, so to speak. Yeah. That does sound simpler.
Yeah. Yep. Well, lesson learned.
I mean, yeah. It's a cost to keep the multiple things updated, I guess. But you do have the flexibility to say, just reuse this particular one for any of them and just only have to maintain that one. But it still is the flexibility there. Somebody wants something that's not quite Dynamo to still.
Yeah. Well, it was certainly a good learning experience. The Cassandra style CQL interface is different and more strongly typed than the DynamoDB. So talking over the Cassandra interface allowed me to push a little more type checking onto the database as opposed to having to do it at the app level. But yeah, it's definitely a hassle maintaining both.
Yeah, my project for work needed to work with MySQL because that's the database that the legacy version of the application used, and the book used Postgres, and they're not as similar as I thought they were. They're not very different, but they're not the same. So in the public version of my app, well, not the public parts of the app, because I released some of the parts as public, that version supports both Postgres and MySQL, and I did it using name of the flags. I can't remember the name of the flags. The flags that you set up in the cargo.toml.
Features.
What it's called?
Features. You just
Feature
select
flags.
which feature you want. Yeah.
Feature, exactly, correct. So then there's features that thing, and if you turn on all of them, then well, I just decide that obviously you must want Postgres because you don't know what you're doing. So so yeah, as long as you don't enable any, then it'll complain. If you enable only MySQL, you'll get MySQL. If you enable Postgres and MySQL, then you get Postgres. Anyway, that was feature flags. So that's what I did for mine. So I don't have any Objective-C code. I literally compile a different binary.
Right. No, with my design choices, well, so one of my design goals for indielinks is operational simplicity.
Right.
I attempted to stand up any number of other ActivityPub-based services locally to test federation, and good God, it was a nightmare. And part of the reason was, they all had so many moving parts. So indielinks, you get a single binary. You can run it as a traditional Unix daemon. You can run it in the foreground. You can run it in a ECS container clustered. That's it. Unbinary. Everything is controlled by configuration.
Yeah. That's the design choices I made with mine. I definitely don't have that flexibility because I literally compile different code, so I can't, can't switch between that.
Yeah, I mean, I see pros and cons either way. Yeah.
Well, for my use case, it's completely fine because I'll only ever need one binary, which is the MySQL one for my actual project, which is what I decided to simplify to once I switched to doing the actual project because maintaining two versions of every single SQL statement was a bad idea.
Right. Yeah. Agree. Definitely came close to ripping it out when I was building out a lot of the storage stuff. Now that I'm really focused on ActivityPub federation and front end, it's not really the pain point it once was.
And in terms of UI, you plan to do a HTML-based UI?
It may look that way, but that just shows my lack of UI experience. I actually wrote it in Rust. The UI is written in Rust. It compiles down to WASM. It's a single-page app, client-side rendered.
Dioxys, you said?
What's that?
Dioxys?
No. Flirted with Dioxys, wedded Leptos.
Leptos. Yeah, the Leptos is the one I really want to try. I mean, Dioxys looks cool as well, but Leptos, Leptos does WASM. Don't they also do like HTML-based one, like they compile down to HTML or something?
You can do either client-side rendered or server-side rendered.
Server-side rendered, and then you just ship HTML.
I believe so.
Okay. Because my introduction to UIs in Rust was eGUI, and since then I haven't really done any of the other ones in Angular. And I think it's partly because eGUI has just made making UI so much easier for me, because I tend to get hyper focused on this could look a little bit different, and shifting things a little bit to the left, a little bit to the right, a little bit up, a little bit more, all these little bits, and it takes a lot of time, not a little bit of time. With eGUI, while I still kind of can do that, it's really difficult to do. So as a result, I don't even try. I just take the default. You know what? It looks okay.
It's one approach.
Give up and give up. That's the best approach.
Say it again.
Just throw your hands up and give up.
I mean, if it bothers me enough, I will adjust it, But 9 out of 10 times, I don't bother to adjust it, and it looks just fine, Functionally, it's there, and it's really simple to just type out what I'm thinking, and then look at it and like, oh, maybe that's good enough. And if I type down it doesn't look what I want, then I guess maybe I might go. I've never in anger tried to move anything drastically, I might just reorder things.
Yeah. My opinion is, unless it affects the functionality that the user receives, don't worry about it too much, and just, kind of keep an eye on user comments once you've got it out there. And then, kind of adapt things and tweak things as you move forward. Because, the color, this color or that color, or, 10 pixels to the left or right isn't, it's not going to make or break a project generally.
Right. The
But
nice thing is that
people find the service useful. It's,
right.
They'll put up with a crappy user interface and then just give you suggestions. And then just
especially when you have a captive audience.
Suggestions.
The
Yeah.
employees don't really have another option to go somewhere else. They kind of have to use whatever I provide. But I think what also helped me to go faster was that I didn't decide to do eGUI long term. It was just get this out in a beta version. Let's get some actual use of the program. Let's make sure everything's working as we actually want. And the back end is separate from the front end anyway. We just switch on the front end later if it comes to that.
Gotcha. Yeah. Yeah. There's something to be said for, ship as early as possible and get feedback from the users. On the other hand, having myself as a user downloaded something that interested me or signed up for something that interested me, and having a poor UX and saying, "Oh, the hell with it, I don't feel like figuring this out," makes me want to reach some bar of
there's some minimum bar you have to reach so you don't chase people away instead of getting
exactly right. Well put.
I think there's a strong distinction between UX and UI, or at least that's what I meant. Is like, yes, absolutely, UX is critical, but when it comes to the actual UI, whether it's blue shade 1 or blue shade 3,
Sure. I concur.
Yeah, it's that kind of stuff that I'm like, focus on the functionality that the user is going to, if it takes them 6 clicks to make a post instead of, click in a box, type what they want, hit post.
Right. Better yet, provide them with a browser plugin, right?
Sure.
Save this link. One click.
Yeah, exactly.
Yeah, that's a much better experience than copy paste, go to the other thing. Honestly, the browser extension sounds usable. The other one, I don't imagine I'm going to do that. Copy paste, go to the thing, put it there.
Yeah. That's right. Yeah, of course.
Yeah. Have you looked into making a web extension along with your service?
Not really. I know it's feasible because Pinboard does it. Pinboard is sort of a successor to Delicious, but it's paid. So I know it is feasible, and I plan to do it. I have not looked into the actual implementation.
I have good news. It's not that difficult either. I was a bit intimidated before I did it, and then once I did, I was like, this really wasn't that bad.
I believe I have to actually write JavaScript.
I chose to, but I
I
think
think you can do it in
might be able to
Rust.
get away with Rust.
I know that there's an example kicking around the Leptos community somewhere about
Yes.
someone
Oh, really?
used Leptos to implement a web extension.
That's
Yeah,
interesting.
Sorry, I
I
just
saw
don't have.
examples with Rust.
Hmm.
But what I needed was just so simple that I was like, it 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 was easier to modify an example and then go actually put the effort in.
Right,
Because
right.
all I wanted to do was just block out the difficulty level on lead code. Because I think it was preloading the difficulty in my mind and not letting me actually just try the problems. So that's all I wanted. I just didn't want to see the difficulty on lead code. So that's all my extension does, just hides the difficulty.
You know,
Gotcha.
I once tried to write a web extension to do similar things, like remove distractions, and it was kind of successful for a bit, but then updates and site changes caused it to break over time. And eventually I discovered that uBlock origin literally just lets you like zap elements out of existence.
Yeah.
And that's just a much easier way to like just remove stuff you just don't want to see on web pages.
+1 to uBlock origin.
Yeah. I heard great things about it, but I'd already run wrong the rabbit hole by the time I found out about it. I was like, you know what, I'm going all the way. And then I found out that I must publish my extension to be able to use it without jumping through a set of hoops.
Oh, interesting. Okay.
So I had to publish it. So I published it. I was like, okay, sure. If you guys want me to publish it, useless extension, I'll publish it.
Cool.
But yeah, it's definitely browser extensions in the plans.
Yeah, 100%. I
for
think
Linux.
that actually might be material part of your actual user experience. Probably also get an option to remove it as well, and probably just light up when it's already bookmarked, things like that.
Mhm, mhm.
Or maybe also have the option to show if it's a trending site, little things like that. I think will
Oh yeah,
make a big difference.
that would be cool.
Okay, so there's a message in the chat. Bunbury said that there's a book on Rust macros, and he also said there's an alternative to I guess Bunbury could speak for himself. In hindsight, he's here.
Yeah. Actually, I'm currently reading this book on macros with the Dallas Rust group. Yeah. So actually, if any of you guys are interested in joining a Sunday evening reading group, I guess you're welcome to come out, check out the Dallas Rust group. Yeah,
Thank
we're
you.
reading
That's
on macros right now. But also, yeah, I was kind of looking into some of these different social media protocols, and I mean, I really like the idea of ActivityPub, and the fact that it's kind of been out there, and it's adopted by the W3C. On the other hand, they have some real issues with scaling.
What do you mean?
Oh, like the actual the server federation itself. They have had servers that have had to defederate from others because every time there's an update published, it gets published to all the other servers and it's amplified from servers, and so you get a whole bunch of extra traffic. And it's actually caused stupidly high bandwidth charges for some server people who run servers. And anyways, there's some foundational issues with the protocol itself.
Oh yeah.
Not to mention the issue with the the primary issue that the AD protocol people point out is just the lack of or the difficulty of moving user accounts from service to service, right? Because your data is held by the server that you sign up for. It's not something that you own yourself. So if you want to move to a different server, unless the server owner cooperates,
Right.
You lose all of your followers, you lose all your data, you lose your old posts.
Yep, concur. Also, I
Shut
mean,
down or can't fund the server anymore, you're hooked.
it's the problem is another problem is it's so loosely specified that you can have two different services that are compliant with the spec but can't federate.
Yeah.
Making sure that your app can federate with, I don't know, pick one, Pleroma, basically means you need to download Pleroma, run an instance locally, and you know,
Yes.
sift the network traffic to see how the hell they're expressing things like follows and likes and comments and notes and articles and so forth.
Oh man, that's horrible. That doesn't sound like protocol. That sounds like guidelines.
That's fair. But
That's
what Mastodon is built on, and that was my first target for federation.
right. So you test with them, right?
Yeah, yep. I and you know, sort of had to hack up a local copy of Mastodon to be able to spy on the network traffic.
Yeah. I also dropped a link in the chat. Yeah, for a Rust lib that's targeting AT protocol.
Does it say Black Sky?
Yeah, Black Sky. Yeah, like it's literally from the Black community on Blue Sky.
I see. Okay. I thought it was a misspelling at first, and I was like, wait, it doesn't say Blue Sky.
I should mention that all the links, or at least I think all the links will be posted in the Discord and the Meetup text.
I can copy them, yeah. They don't get automatically posted.
Yeah, they're not automated, unfortunately. Maybe that's something we
Yeah.
can do. Write a little Rust tool.
You know what?
Automatic.
If Bunbury is okay, I'm just gonna copy paste the whole chat. Anybody has a problem with that?
I mean, if we get because we are recording, we're also going to have the transcript, so I guess we could potentially include the chat.
Okay, yeah, just post a transcript. That's also,
Yeah, that's possible.
But now I just copy pasted it.
Yeah, if you already copy pasted it, then whatever, it doesn't really matter.
I mean, I'm on my computer.
Yeah, like why not, right?
Yeah. But thanks a lot, Michael. I really appreciate the presentation.
Thank you.
Really good.
Yeah, it's really great so far. Great job.
Thank you, everybody.
Yeah, and you made a lot of progress.
Mhm.
You keep on saying it's not there yet. I was like, wow, you've gotten quite a bit of the way. How long have you been working on this?
Probably about 10 months part-time.
Wow.
It's about 35,000 lines of code now.
Your part-time and my part-time are very different.
You
I think I've done less of my full-time project.
got a lot of other projects on the go.
That is part of the problem. Too many projects running at the same time.
Yeah. I came up with the idea in early 24 and sort of spent a little time picking at this and that, like, well, how would a web finger work? And what does an activity pub follow look like? And what would the data model look like? Kind of around the holidays last year, it all came together and I started writing production code.
Very cool.
Yeah. And fortunately, one of the nice things about Rust is it helps you repair sins, you know? If you make a mistake early on and you decide you need to refactor, it's not as traumatic an experience as Python.
Or any other loosely typed language,
Exactly.
like dynamically typed.
I think the problem is in Python, the types, at least I guess I wasn't using one of the strong type checker things. You know, I define my types as much as I could on all the hinting type hinting thing. But you don't get a type error if the type is wrong. You just get some other error.
Oh.
Yeah. So in my case, I went from a list of strings to a single string or the other way. either way, instead of iterating over strings in the function, it started iterating over the characters. Yeah, and then I got weird results, and it happened so far away from where I made the changes that by the time that happened, it was just so confusing. I was like, "What did I do? What's happening here?"
Yeah.
Yes. Trying to develop anything non-trivial in Python is truly a nightmare.
It was better than all the other things I tried before that. Well, not all, but it was better than JavaScript. Substantially.
There are a
It
lot
was
of
less annoying than Java.
JavaScript. You know, when I wrote
Sure.
that web extension a while back, I actually did it in PureScript because I was just like, oh, hell no, I'm not touching JavaScript.
I mean, JavaScript is just an interesting language, you know. It made a lot of interesting choices that bite me all the time, like sorting arrays of numbers still sorts as if it was strings, because that's how it's implemented. So the last 2 months in the year last 3 months in the year, sorry, come like after
Right.
January. I'm like, how did this happen? I'm very sure I sorted them so they wouldn't end up in the wrong place. And I sorted them and put them in the wrong place. Like I was very careful to make sure they were all numbers, so it would sort them as numbers. That's what I assumed. That was a wrong assumption.
Yeah, you can do some truly impressive but also very nightmarish things in JavaScript.
Yeah.
Yeah. Thank goodness for Rust.
You say that like yeah, but it's not just a meme. It's real, man. It's it's real.
I will say +1 for that parse don't validate slide. I really
Yeah,
agree.
plus one for that as well.
Mentality and definitely. There's so many times at work where I see people trying to like validate things and they end up in all sorts of weird like Boolean blindness situations, and I'm just like parse don't validate. Over to the Haskell link, and I'm like, this is this is like a better way to do this stuff. Unfortunately, like a lot of us don't know how to read Haskell. So.
And it's just so much easier to scale. You don't have to repeat that work all over your code,
Yeah.
Yeah.
Why
Once
not
you see that,
save yourself?
once you see that approach, you can never go back. I don't, at least not in good conscience.
Yeah, no, definitely not.
They're just some things that you see in your life and you're like, okay, I can't unsee this, I honestly think that even if I went to a different language, like I moved back to, I don't know, if I had to move to something else, I don't think I'd be able to go back and leave some of the things I learned in Rust. Like Rust makes me write different code, even in other languages now.
Yes. I found the same thing with Haskell and Idris as well.
I feel like I'm consciously way more aware of like memory ownership when I'm writing C++ now. After having written Rust, like I see someone storing a reference in their struct, and I'm just like, but like, what's the lifetime on that, huh? Like there's always little things like that you gotta look out for. It's like, I'm used to Rust just like looking out for these things for me, and it's nice to like be able to take that kind of thinking and like transport it into another language and be like, like the reason why this thing is not working anymore, or like I'm seeing this weird undefined behavior is because the ownership wasn't transferred for this data type, and so then it got dropped, and it got deallocated. There's now just a dangling pointer, that kind of thing. So yeah, really appreciate that.
There is one thing that I've noticed that I quote unquote lost after I started using Rust is that I have a much harder time debugging code now than before I started using Rust. I guess I had a better intuition for where I made mistakes before because I made a lot more of them. But
well, as you move to more and more expressive type systems, you move bug detection further to the left in the compile and the edit, compile, debug cycle. The same thing happened to me many years ago. I interviewed for a role as a senior C++ dev, and the first half of the interview was about the language, the usual gotcha questions, and I felt comfortable. The second half was about debugging, and that did not go so well. And when I thought about it afterwards, I realized it had been a long time since I'd had to do a lot of the debugging procedures that they were asking about, because I'd learned to use the type system, such as it was in C++, to rule out a lot of these bugs in the first place. And I was more and more used to fight the compiler, fight the compiler, fight the compiler. Oh, shit, it just
Working.
works. Yeah.
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 And I found that on steroids with Rust and Haskell.
Yeah.
So, correct by construction approach
Yeah.
really makes a huge difference. Like when I'm writing C++, I feel like I absolutely just cannot write this code unless I have LLDB running. You know, like I need LLDB to write C++ code. When I'm writing Rust, it just, you know, I don't necessarily feel like I need to like pop open a debugger and, you know, start stepping through the code all the time.
Yeah, exactly.
So I'm not sure if you guys are familiar with like leak code problems, specific problems. I was doing the LRU problem, least recently used cache. And basically you have to write a cache where on average in constant time, inserts and lookups. So, you know, you need to have a linked list to keep track of the most recently used one. So you just pull it out from the list and put it back to the front every time it gets looked up or put in, you know?
Right,
So it's fairly simple to do in terms of conceptually after you get it. And you have a hash map to look up the actual values. So all that's fine. And, you know, I can write it in Rust, but it takes me like about an hour to write, because I always, you know, have to, because the W linked list, and I have to always remember to use the weak links going backward and all that. You know, it's not complicated. It's a bit of typing, you know? So I decided to try to do it in Python. I was like, okay, I've tried it in Rust twice. The first time took me about an hour and a little bit. The next time took me 47 minutes. I was like, let me just try it in Python and see how fast I can do it. And I got it done in about 20 minutes. And then I spent about an hour trying to find where I made the mistake.
Yeah.
I was like, I don't know if this was better.
Yeah, well, yeah, that's what I found is like, I mean, why would
All right,
you
okay, man, have a good
bother?
night.
Thanks for coming.
Yeah, thanks for coming out. Yeah, like in my opinion, like why would you bother spending all that time looking for a mistake unless, like, rather than just building it right and, you know, having it be there for when you refactor in the future.
Sunk cost. I wanted to know why it wasn't working.
We were, at my last job, we were introducing Rust to the engineering org, and the first team that adopted it were eager to do so, right? So no difficulty selling them on the idea. But other teams raised on JavaScript and Python found the idea of a compiler extremely intimidating, more at an emotional level than an intellectual level, I think.
I agree. That's kind of been my experience too, especially with a lot of the younger candidates these days that come in. They always are raised on, you know, Python, JavaScript, and they're so used to that interpreted dynamic typing that they just don't really know how to deal with compiler, and they're always like screaming about the compiler errors and like, oh, and then like their benchmark of success is like, oh, when you get it to compile the first try, you know, that's, you know, that's like the greatest thing ever kind of thing. And it's like, yeah, I mean, kind of, but also, you know, the compiler's there to help you. It's supposed to guide you towards writing more correct code. So
I guess if they don't experience a bad compiler, they don't know the difference, because I started off in Pascal, and the Pascal compiler, in my opinion, was written for the person writing the compiler. Something they didn't understand. They're like, I expected a semicolon, I didn't find it. You know, just simple as that. And they just like, I'm done with you. You figure out what you've done wrong and go fix your sins and come back. So you look at where the error is and you guess around there. Something around there is wrong. What looks wrong?
I was reading Types in the Programming Languages by Benjamin Pierce, and he mentions, like, pretty early on in the book, how he believes that you know, type systems get a really bad name because a lot of languages that are commonly used in the industry don't have very good type systems. They don't have very strong type checking, and they don't have good like static analysis, which leads people to end up hating their compilers. And so I think that really I feel like you're kind of like treading that same sort of ground there, kind of that same sort of realizing. Hello.
In the end, anybody want to take a guess what the problem was between Python and Rust? What was wrong with my Python version? In Rust, when you want to take a value out of a option, there's a take function that will swap out none and give you the thing that was there, none of the sum. So I use that in Rust all the time because it just always syncs with how my brain thinks about it. I've taken it, it's mine, you don't have it anymore. I don't have to worry about clearing your value. In Python, you can't take the value. So I just copied the value and then it still had it. So I thought things were set to none, and they were not. They were still pointing to what they used to point to.
That's always frustrating.
Of course.
Yeah, it just increments the reference count, right?
Yeah, exactly.
Yeah.
But it was just a mess. I was like, oh man.
Yeah, I really appreciate that Rust actually makes you think about like what's being passed by reference and what's by value, that sort of thing. And it's very consistent about it too. Not a lot of like weird edge cases there.
I remember when I first started doing lead code in Rust, it was rough. That's a fair description of it. It was rough. But now I'm like 100% prefer doing lead code in Rust than in any other language. Some of the problems I'll agree take a bit more typing, but I can also type up my thoughts. I type up my thoughts on the solution, and then I just finish with fighting the compiler to get my thoughts working. Whereas when I do it in Python, I got to run it and add some print lines, and it's not fun. As well as local testing, Python is not as easy for me to get. At least I haven't figured out the easy way to get local testing working for me with the Python lead code stuff. With Rust, I was able to write a little tool that will download the test cases from lead code and set them up in the Rust thing at the bottom. Same in the same file. And just test all the things for me, and I can just run all the tests. And it's so much more fun to lead code like that. Locally, you get that instant feedback loop. Beacon running there, just popping up on the other screen, telling you, "Oh, this doesn't work. This one doesn't work." I don't know. It's just.
No, I agree. Like I definitely started migrating away from other languages slowly. Like every time I'm deciding to like work on a new project, it's just like, well, I could pick this one, and it has like these libraries, and these are pretty good, and that's cool. But I honestly find myself gravitating towards Rust a lot more often now. And even for projects like, I'm trying to write like a compiler, and like Haskell, very strong consideration there. But
did you just say you're trying to write a compiler?
Yeah.
Did you just say you're trying to write a compiler?
Yep.
For what
Okay,
language?
that's what I thought.
My own language. Well, it's going to compile down to a somewhat. It's not an assembly language. It's a scripting language that only has like go-tos. There's no like pointers or function pointers or anything in it. It doesn't even have like Boolean operators or Booleans.
Ask the wrong question. Why are you trying to write a language?
Because I don't want to work with the target language. I don't want to have to deal with all the go-tos and like the lack of like they only have if and else. They don't have and, they don't have or. You could like write your own, but it's like it's just really.
How do you get by without if?
How do you get by with just if and else?
How do you get by without if?
Without the if? I don't know.
How do you create an if without an if? I mean, if seems like a fundamental language primitive.
No,
yeah,
no,
you need Boolean to use an if.
Repeat that, please.
Well, in order to use an if statement, it requires the concept of a Boolean of truth or falsity.
Exactly. Yeah.
Right. Well, they don't have like a primitive Boolean type. They just have integers.
So how are you implementing if in your language, in the base language doesn't have it?
Sorry?
How are you implementing if in your language if the base language doesn't have it?
No, it does have if. It has if, and it just checks if. Um, so it has like certain things baked into it, it has certain conditions baked into it. But I can just like check if variable is equal to 1 or variable is equal to 0, that kind of thing.
I see.
Well, the language itself doesn't really have like static typing. It has a concept of like integers and text, which is also very like loosely defined. I'm a little bit worried about how to deal with that. But I don't know, we'll cross that bridge when we get there. I honestly do want to talk about this a little bit more once I'm a little further along with the project. But I've basically built like a simply typed lambda calculus implementation on top of this because I could not stand. So I'm sorry, but like the target language was just really awful to work with.
This is a little scary, Jonathan, but I was reading Types and Programming Languages by Pierce, and I started writing an implementation of the simply typed lambda calculus in Idris, in my case, and thought it would be interesting to sort of write a language along with Pierce that would compile down to the lambda calculus.
How did you find that?
Interesting, but it's sort of been put aside for indielinks for now. I'm hoping to get back to it.
Oh, interesting. Okay.
Sorry, what is this book that you're referencing?
Types and Programming Languages by Benjamin Pierce. Let me get you a link.
Actually, yeah, I was actually doing that at one point too, and then I put that down for a different project at some point. I guess now it's been replaced by this current one that I'm working on right now. But I guess I sort of came full circle in a way. But like the language I'm compiling to is relatively high level in some senses. Kind of low level, but it's not as low level as like assembly. So I don't know, I feel like it's pretty doable. I have some like very basic code generation in already. So
What I'd love to do is build a an imperative language with dependent types, right? So I want proof terms with no runtime.
right.
I think that would be very powerful.
Interesting. I considered dependent types because I'm actually basing my compiler off of the Pi4All compiler from the Oregon Programming Language Summer School course. They implement dependently typed programming language called Pi4All.
What's it called?
The course or the language?
Well, I know I'm familiar with Oregon Programming Language Summer School. What is the implementation of dependent types that you referenced?
Oh, the implementation, I think it's just regular like Martin Clark. So nothing super fancy. It's not cubicle or anything like that. It's dependently typed.
Okay.
It's anything fancy like typecase, but I don't. It sounds like you don't even want that because you don't want to have like types living at like runtime. So it's I would recommend checking out Pi4All. There's a GitHub repo, source code's up there.
Pi for all?
Yeah,
like
Pi-4All. You know, like pi as in like pi types, like the.
I see. That makes sense.
But yeah, it was a really good course. I think it was like the 2022, 2022 or 2023. I think it was 2022 though. The summer school. They had a course by Stephanie Weyrich, I think. I don't know. It sounds very German looking name. Don't know how to pronounce it, but yeah, it's a really good course. They implement a dependently they implement a dependently typed language, and the type theory they develop these bidirectional rules. So it's actually really really easy to follow along and get started with that. and they have all the source there. Like if you want to see like how the parsing works, how the type checking works, how they handle like declarations, definitions, the context, the environment, that's all in there. I think the only thing it might not have is actual code generation. Like I don't remember if you can actually execute stuff, but it doesn't really matter. Like code gen is kind of a sort of separate thing anyway.
Yeah.
Have any of you guys used Zig?
I have not. Should I?
I would say sort of, but not really.
I've never really done much with Zig. Like still haven't tried it, but I listened to a podcast recently. I can't remember when. I'm not sure if you guys have the Rock programming language.
I've heard of Rock.
You've heard of Rock, yeah? So they're rewriting the Rock compiler from Rust into Zig.
Why?
And why? Because they had to rewrite the compiler anyway. So it wasn't because Rust was a problem, it was because they had to rewrite it and Zig was a better fit.
Interesting.
I don't know why anybody would not use a type-safe language for systems programming now. Like, you actually want to get it adopted outside of like hobby programming, like any kind of like, you know, public sector or even private sector work that
I can share the link to the podcast. He I don't remember his arguments, but when he described it, I agreed with his decision. So I guess he made a good case, and or I was sufficiently tired that, you know, I couldn't think for myself. But by the end of the podcast, I was like, you know, I think for him it was the right decision. It's just like I'm very tempted to choose Rust sometimes when I know it's not the right decision. Like I'm working on a program where I need to interact with some Google Sheets. And if I write it in JavaScript, or at least TypeScript, if I write in TypeScript, then Google will run the code for me. If I write in Rust, I have to stand up a server. I have to run that myself. I have to deal with the any breaking changes in the API. Not the API. The API, I guess, is pretty stable, but the Rust library for the Google API is under active development. Google is working on one. So, you know, I mean, Rust would be, I think, a bad choice, but at least for the compiling of the spreadsheets, I'm still going to do that in Rust, so I'm still going to have to deal with that at some point. Right now, I'm just downloading the Google Drive.
So what's the elevator pitch for Zig? Why should I use it?
Zig, elevator pitch for Zig is if you need to use Rust unsafe primarily, then use Zig instead.
Yeah,
if what you need to do requires mostly unsafe Rust, then use Zig.
Yes.
Why Zig over C?
Why Zig over C? Because C is
C is the nightmare. Zig cleans up a lot of cases.
Zig is
here's an
Zig
example.
is a friendly version of C.
I can give you a concrete example of something that Zig does better than C and Rust. It's null pointers. It actually, like Rust, I think makes all pointers nullable by default, or at least like raw pointers, but Zig doesn't, even in unsafe code. So
Rust unsafe code is challenging to write compared to Zig. That's my understanding of the elevator pitch for Zig. So if you're going to write primarily unsafe code, then you're probably better off using Zig than using Rust.
Yeah, because they don't have like that separation between like quote unquote unsafe and safe. Because Zig doesn't have any guarantees that your code is safe. It's not managed or anything like that. It doesn't have like a borrow checker or anything similar, but it generally just like by just better practices and a little bit of extra type safety, it's better for writing stuff that is just very heavily going to rely on safe anyway.
And they have a lot of runtime testing and analysis. So they'll help you detect memory leaks, they'll help you detect the things like because you have to pass in the allocator. So they can, because they're passing the allocator for testing, they have a special allocator that can track the allocations and stuff. So, it's not completely just Wild West,
Right.
Right, but it's still fundamentally unsafe. Whereas,
so is Rust.
well,
I mean,
if you were just to compare C with Zig, I would say
Mhm.
go with Zig.
Yeah.
But now that Rust has entered the conversation of systems programming, yeah, I don't think that Rust's unsafe programming model is awesome right now. But there's work on making it better. But the important thing about using unsafe with Rust is that it is segregated and defined in your program as unsafe. And if you check that extremely thoroughly, you can build a safe interface on top of that, and then use that safe interface to, write the rest of your program. You can't do the same with Zig. It's just all unsafe. There is like and further along with that, it's like, so not all of a Rust program needs to be unsafe. So for the parts that you can write in safe Rust, you should write them in safe Rust. It will make your program overall more safe.
I've never written unsafe Rust. I've been using Rust since 2002, I guess, about there. I've never written unsafe Rust. Like I wrote unsafe Rust once to try it, just literally just to try it. I didn't need it. I've never needed unsafe Rust yet.
The only, I mean, if you want a really easy way to start getting into unsafe Rust,
FFI?
FFI or embedded.
I've not done either yet.
And I don't know. My experience with Zig was like, I think it's cool conceptually, but I think it has some not necessarily like language problems. I mean, like obviously, yeah, like safety is one of those things that kind of makes you go like, because it's not. It doesn't have any kind of safety guarantees whatsoever. There is no separation there between safe and unsafe, and so in the end, it really is little more than just like a better C in a lot of ways. But consequently, that means that it's in direct competition with languages like Odin and Jai as well. And those are also aiming to fill that exact same niche of just being a better C, except with different, syntax, different, approaches to things. And I feel like that kind of fragments the ecosystem there a little bit. Like it doesn't really try to do something that's super like unique and novel in that sense. And so I feel like because of that fragmentation in terms of community and people picking different languages based on what they want to do, it's kind of led all three ecosystems to kind of starve a little bit. Like I think the last time I picked up Zig, I tried to play with some kind of Postgres driver or something. I can't remember what it was, but it like literally hadn't been maintained in like 4 years or something like that. And I tried to compile it out of the box, it just didn't even compile. And yeah, it was not really the greatest experience compared to like something more mature like Rust at this point is. And so that's kind of why I don't think that Zig in a vacuum is like terrible or bad. I think it actually does improve on a lot of things that C does poorly, but it's just it's in competition with other languages. I think it might be the most popular option right now of those options, but you never really know what's going to happen in the future either.
Right, but Zig is still insecure by construction.
Yeah, all three of those languages are.
Yeah. So I mean, I hate to say it, but the industry has already decided, and they're moving to Rust.
Yeah.
Evident.
Largely, it seems that way. I mean, Zig still finds its way in like
Just
little
if you
niche use cases, right? Like obviously Bun is one of those cases, and I think Zig build, like Rust, relies on Zig a lot for cross compilation. So it's kind of it has kind of nestled its way into certain niches, but yeah, definitely not taking up nearly as much of the mind share, I guess, as Rust seems to be.
Bunbury, what leads you to say the industry has decided on Rust? I mean, still see a lot more jobs for C and C++ devs than I do Rust devs.
Oh no, I think you
Absolutely.
meant in terms of competing languages.
But those are working on pre-existing projects. If you
Not
look
always,
at
actually.
projects that are starting, in terms of anything that is safety critical, whether it's the automotive industry, the aerospace industry, the space industry, anything that works on public infrastructure, trains, even a lot of embedded devices now, they are all moving to Rust.
Mm.
I mean, militaries, NATO is moving to Rust. Linux, the Linux kernel is moving to Rust. Linux has not adopted. Yes, there's been a lot of chatter about it, but
Chatter's not the right word. I feel like disagreements is more.
right.
Well,
But if
I
you
don't know.
look at the statements from Linus and sorry, what is the number 2 guy in Linux?
We can call him number 2 guy. That's fine.
I don't know.
Yeah,
don't
the number 2 guy who's been focused on like Linux compilation and reliability for 20 years now. Look at his statements on Rust. Like, Rust can solve problems that just have existed in C for years. There's a reason why, the US DoD has started that tractor project, to try to convert C code to Rust. It's not, tracked as, convert all C code to Zig. They want a safe by construction language. And eventually, not right now, because there's a lot of existing code out there, but eventually, more and more projects are going to be adopting Rust. It's what all of the major tech players are adopting. Microsoft is slowly converting Windows into a Rust base. Yeah, I mean, Linux has adopted Rust. There's even rumors about Apple adopting Rust.
Really?
Yeah.
Like, don't you have Swift though? Isn't Swift very similar?
Yes. Well, Swift is a garbage collected language. So in areas where they've been using Objective-C, which is, what they use at the base of their OS, because you can't use a garbage collected language for some use cases. Yeah, they're looking at Rust.
Right, but I thought they were
To
implementing
mention AWS and all the stuff going on at Amazon around Rust. Like,
okay, that's true. You can't deny that. Yeah, there's a lot of new Rust projects that we've gotten, just like from our clients, because we're a contracting company, right? And we've gotten a lot more Rust projects recently, because a lot of people are writing their new projects in Rust. But
all right.
no, I'm not sure. I'm really not sure what the future is going to look like, honestly.
Yeah.
Because on the one hand, I kind of agree with you, but here's how I see it. Like, there's a lot of new blood in the programming scene, and a lot of these people were, they've grown up with like JavaScript and Python mostly, I would say, and so a lot of them kind of already reject compilers. So I'm not really sure like if Rust will ever be that popular with them. I feel like they're all going to want to stick with Python or whatever, just more managed languages to begin with. I guess there will always be those niche cases where Rust can shine. And I guess if they ever have to, write low-level projects, I guess they would probably pick Rust over C or C++ because I know a lot of those same programmers can't really deal with the complexities and history of C and C++. I feel like we're kind of experiencing that personally right now, like on the current project that I'm working on with C++, and my teammate who picked up W chars and started using those without knowing that people kind of stopped using W chars 20 years ago, right? Like, there's a lot of and
Are you on Windows? Are TCHARs still a thing?
I'm not on Windows, but
Okay.
he was on Windows. He was basically developing everything as if everything would just work on Windows. Right? Like if it works on my machine, then like hopefully it'll work everywhere else. But then
How many devs did it take to screw in a light bulb?
yeah, and then the problems start to arise, and then you have to kind of start undoing everything, backtracking, and thinking about encodings, and realizing that but the W char is it's 4 bytes on Mac and on Linux, and it's not going to be necessarily 2 bytes. It's just I feel like there's a lot of these issues that Rust kind of sidesteps or solves entirely, and for newer projects, it's going to be great for replacing those kinds of projects.
Old,
I don't know.
old enough to remember when we thought 2 bytes was going to be enough to encode everything.
And
I can't even imagine that.
Oh, yeah. I mean, it was a selling point for Windows NT and Java in the 90s. They were UCS 16 natively. That was still modern.
Wow.
Yeah. Well, thankfully we learned the hard way, but
we got there.
Just do it in UTF-8 everywhere.
And I mean, Rust isn't perfect. I mean, you guys have heard me complain about, Rust's model of futures. I'm not saying that Rust is the be all and end all of, of programming forever. But I think that it's the best systems programming language we've got.
In the here and now, it definitely kind of feels that way. I mean, I've still seen complaints from some people about like, it doesn't support my platform. Right, like they're doing some like weird embedded project. I mean, I shouldn't say weird, but there's a lot of different architectures out there, and it kind of makes sense why they might still want to choose C or C++ in those cases. But generally, I would kind of agree that it feels like the best systems programming language at the moment and in the near future. But yeah, beyond that, I don't know.
Honestly, I feel like Rust is, for me at least, the ideal scripting language. I can take shortcuts when I want to just get something working, and then I can always come back and Control F to find where I took shortcuts. When I take shortcuts in Python, start again, buddy. Just scrap this one. I think that's the biggest thing for me, honestly, the refactoring. I think I really, really, really enjoy the ability to force a change to everywhere by just knowing the compiler won't miss any of them.
I think Michael's future language with dependent types, I think that one's going to be the best scripting language.
Yeah. Actually, are you guys familiar with linear types?
Yes.
Yes.
That's I wish
Correct. That's the ones that must be used exactly once, right?
Yep, must be.
Yeah.
It's not affine like Rust's type system.
I don't know how I feel about them though. I feel like they maybe there's a warning to disable must use, because I'm like, most code won't compile.
Yeah,
Oh,
I'm not sure.
yeah,
how
they definitely need to be optional, but it would. I think that would be the right model for futures.
That's what they've said. Yeah, that would work better for futures. I mean, I don't know. I think that there are definitely issues there, though. If they tried to do linear types, like how would they handle?
You can't use an entire language, like you can't write everything with linear types.
Yeah,
Yeah.
I feel like it would be a problem if you like started writing FFL code. You need to explicitly like do a box leak or something. Oops, you can't actually leak things because everything has to be consumed. I mean, I guess you could maybe add some kind of state patches and like kind of go outside of the core type theory that way, but I don't know. I mean, I thought
that's why I say they need to be optional.
I think Idris's approach is really interesting with like QTT though, where you can like specify multiplicities. So you can say like this thing has to be used exactly once. This thing is erased, so you can give like a multiplicity 0. Or you can say you can give like exact usages as well.
Sorry, and that's in Idris?
Yeah, Idris has that.
It's called quantitative type theory.
Yeah.
I don't really understand it very well. I know 0 means it's erased at runtime, but that's all I understand.
Yeah, it's like
That
linear.
one's easy to understand.
Yeah, one is linear, and then I think the other multiplicity is just like you can reuse as many times as you like. But I seem to recall someone, it might have been like Guillaume LA, he might have figured out a way to encode like arbitrary multiplicities using that implementation of QTT. But I think someone else also created like some kind of gradual. Actually, I don't remember what it was called. There's some other system where you could actually explicitly say like, oh, I want to be able to use this variable exactly 2 times or 3 times as well.
I feel like I don't know how many times I'm going to use the variable when I make it.
Sorry?
I feel like I don't know how many times I'm going to use a variable when I make it.
Yeah, that's kind of why Idris doesn't have that feature, because they're just like, well, if you know like this type is going to be erased, then you're going to mark it with 0. If you know that this is going to be, you want to use this like yearly, then you put it with a 1. But for everything else, you just give it like the infinite multiplicity.
Yeah.
Yeah.
And that's pretty practical, in my opinion.
Yeah, bringing it back to Rust for a second, what I think would really help with, learning and adopting Rust would just be like better visualization to go along with the borrow checker.
Yeah, actually, I thought about this like so many times, especially like with lifetimes as well, like having those little like scopes that they like sometimes show in like the book. I don't know if they still do that, but like having just a little more visualization to actually see how long certain references last and stuff.
Yeah.
Doesn't the compiler show that?
And who owns certain things. I think
Compiler
there might,
show that?
there might be some static that does that, I think. I don't remember. I certainly haven't played with it.
I've started. I pulled down the code for the Rust compiler, cargo, and Rust analyzer, so I can start digging into that and try to figure out how to start visualizing that effectively. But yeah, if anybody has any ideas,
Am I mistaken that the compiler does not already do it? Am I imagining that?
Well, what we kind of need is to display that in a text editor, right?
Yeah.
I mean,
The
because
compiler
like
doesn't do that right now.
information.
Doesn't do it for me.
Oh,
How does it do it? I'm using Rust Analyzer and Emacs.
I basically use Beacon, so I'm just using the CLI. I'm trying to figure out well, the thing is, I hardly ever run into lifetime issues, right? So maybe it's just my imagination. Maybe I'm remembering.
I've gotten error messages where the compiler will say, this reference is dropped here, and actually does a little ASCII. Yeah.
Okay. Because I'm like, I feel like it was the compiler that told me those things, as well as if I double borrow things or whatever, I move things that were dropped or whatever. It always tells me where, and I've never had to. There was one time, like early on, I think I was doing some iterating or something, like probably same like a couple months after I started Rust, and I did something weird, and it did something weird in response, and I couldn't figure out how to provide a better error message than what it provided, because I did go to the Rust Discord and I was like, hey guys, this error message is cryptic. I figured out what's wrong, but not because the error message told me, but I couldn't figure out how to fix the error message because I had just written some really weird code because I didn't know what I was doing, right? I was super green to Rust. I was just, trying to get things to work. And
Mhm.
I ended up with some code that I probably cannot write again because it just didn't make sense.
Yeah.
But, I did write it, and the compiler couldn't help me. And I couldn't figure out how to tell the compiler what it should say that would have been helpful. I don't know.
So I think, yeah, clearly the knowledge must be there somewhere in the compiler. It's a question of.
Well, yeah, it was
Yeah.
wrong. I think I was using something after it was free or something, but because of
Yeah.
I can't remember. I'm not
Yeah.
even trying.
Yeah, it just needs to be displayed so that like we can actually understand what's going on underneath the hood.
Yeah, I mean, like it would be really powerful if you could, mouse over or put the cursor over a variable and in your IDE have the lifetime highlighted.
Sure.
Yeah.
That'd be a good teaching tool for sure, even if it's not. I think the part of the problem is that I've been doing Rust long enough now that I can look at them and see it overlaid in my mind, kind of thing. Like
Mhm.
I see the lifetimes, right? I see this thing. Oh, this lives as long as that. Okay, sure. And because you either see it on the screen or it comes in via the type annotations, right? The lifetime annotations. Because if it's in a function, then the annotations tell you what the lifetime is. So
Right, but it doesn't necessarily show you where the where a variable is dropped, right?
yeah, but what I mean is like I see it, So
Well,
like I get what you're saying. It would be helpful for beginners, maybe, but
Yeah.
Say again?
For beginner scenarios.
Because once you violate where it's dropped, if you try to use it after it's dropped, it will tell you it's dropped on this line. So even if it doesn't like draw it, it will tell you exactly on this line is where it's dropped.
Right. What I'm trying to get across is that it would be helpful to know that before you even run the compiler.
Yeah.
I see. Okay.
There's also
Okay.
places like higher ranked trait bounds that are kind of hairy. There was like one time at work where like a coworker was asking me about this like weird case of where they had to use lifetimes because they were like super allergic to using box apparently on that project. Apparently the solution was to use a higher ranked trait bound. He's like, this is like the one time I've ever had to use this. It worked for us, but like it's so hard to figure out like what was going wrong and how to get the lifetimes that we needed. And I don't know. That's one of those kind of cases where I'm just kind of like, because lifetimes can get pretty, tricky.
Yeah.
I've never run into any serious issues with lifetimes or needed to use unsafe, so I guess I'm still very new to Rust. I've only had to use the easy parts.
Oh, yeah, it just depends what kind of projects you're writing.
Yeah, my projects are pretty simple, just like web servers, simple UIs.
Yeah, like my personal projects, I never have to deal with unsafe because I'm just like, I'm writing stuff where I know that it's going to be in relatively safe territory and I can design it the way I want to. It's, design from scratch from the ground up, but it's not like reliance on anything else. I don't have to like write this for some kind of enterprise, right? But like when I'm working with Rust, it's a pretty different story because that's when it's like, oh, but we have to make sure that we accommodate all the Java programmers and the Python programmers, and they want to be able to interface with our product, but they don't want to switch to Rust. They don't want to have to write their project in Rust. So we have to use FFI, and so then we have to get into all the weeds of doing everything in FFI, and that's why a lot of our projects a lot of our client projects that we take on, all the contracts that we're taking on in Rust, they're almost all FFI projects because
Interesting.
some kind of core being written in Rust and then some wrapper languages around it that are used to help people, write their Python code and get the performance and safety of Rust without having to actually touch Rust directly.
Well, I mean, that's what Python is good at. I have to give them that because you never know you're using C++ when you use Python.
Yeah, exactly. It's just that a lot of these projects, they used to wrap C, they used to wrap C++, and now the new projects, they're all just wrapping Rust instead.
Yeah.
Mhm. Yeah. But I mean, as an individual developer, there's still like, I mean, if you wanted to switch between, Python and Rust because you wanted to write like, like a, I don't know, controller for an LED light for your bedroom, like getting to know the entire, set of libraries and the syntax for Rust is like a huge switching cost. Whereas, like, if you just like learn one language like Rust, where you can like write a web server or a website or um, an aeroplane operating system, uh, like you use the same libraries, you use the same tool set. You don't have to like figure out a new syntax. Um,
Right, it's the
and it's
same language for the entire stack. But like the Python, I guess, gamble, it's not really much of a gamble, but the Python gamble is just that since it's so popular, there's probably a library for that already. Someone has already written something that wraps Rust or C or whatever and does what you need.
Because Python runs on microcontrollers, man. MicroPython.
Yeah.
right, but it doesn't run fast on microcontrollers.
It doesn't run fast anywhere. But it's honestly, I don't find Python and Rust as different as other people find it. You add a couple more letters, okay,
There was an old saying that Rust is just Python with braces.
yeah. Get rid of that stupid white spacing thing, and there you go. Add some letters, couple brackets, everybody's happy.
There was this old picture where someone like photoshopped like a python and it had like a big set of white teeth and some braces on those teeth.
Braces on the teeth, I get it.
Yeah.
Yeah, I don't know. My previous language I was using heavily before Rust was Python, and I didn't find the switch shocking or as different as I expected. I really expected it to be drastically different than Python. I expected I expected a substantial learning curve, I guess maybe because I dabbled around the idea of Rust for so long before I decided to try it. That by the time I did try it, none of it was new to me anymore. Like I understood the borrow checker, I understood all those things before I started writing any Rust, because I was really trying to evaluate if I want to invest time in learning a language that nobody seemed to like except for the people who use it. Because there's so many people saying Rust is the best, and then there's so many people saying Rust is hard. I was like, some of the people saying Rust is hard, I've seen people saying Rust is the best. I was like, oh, well, only thing that seems consistent is that it's hard. Why am I going to do this?
Yeah. Well, I mean, it's hard if you don't really understand anything about how a computer works.
Yeah, maybe. I don't know. I understand that Rust is hard for some people, but my expectation is that it's really hard for people who have a slightly incorrect model of how computers work. I think that's when it's hard. When you have to now change how you think about computers, Rust is hard.
Yeah, I think when you have like some preconceived notions that like, maybe you're used to, I don't know, just doing functional programming, for example, and everything is just like passed by value, then you're getting used to thinking about like the heap and memory and pointers and stuff. It's a little, it can be a little bit tough. But I think definitely for a lot of the people who are used to managed languages like Python, JavaScript, and never think about the heap. Like I think the benefit you had is you probably have at least thought about like the difference between like the stack and the heap and that sort of thing. A lot of programmers don't. They don't even like really realize that there's like this distinction under the hood. They're not thinking about those kinds of things at all. They're just thinking about logic.
Before Rust, I would say that my knowledge of the stack and heap was mostly academic. I mean, a little bit in C and a little bit in C++, but for the most part, it was purely academic because I couldn't see the performance difference in the applications I was writing. So whether it's on the stack or whether it's on the heap, it was all too fast for me to perceive the difference. So I didn't feel it. In Rust, I started writing applications that started pushing the boundaries of the hardware a little bit more. So the differences in allocations actually started to matter, as well as I guess I had more measurement tools at that point. But I don't know. I mean, I did come in from like manually memory manage, a language where they manage memory manually. So I was using Delphi before that, which is what I was really looking for a replacement for. Delphi is like a object-oriented version of Pascal, and in terms of building UIs, it's the application I've enjoyed building UIs the most because it was fast, it was easy, and it was native. So you would build the UI once, and it would compile down to the different platforms for you. So you'd get Android application, iOS application, Windows application, all just building it from one UI. You know, so it had that feeling of write once, run multiple places kind of thing. It wasn't everywhere. It was only those three I mentioned, but you know, it's still more than none, right? And I was looking for something to replace that. They had these UI builders in Java, but they were pretty bad comparatively. You know, they were not what you see is what you get, and they would always have this kind of clumsy look. Whereas with the Delphi ones, you know, you got these professional looking applications. You know, the applications looked like Word and Office. It looked like things that I used. You know, it didn't look like a kid made this, and I was a kid at the time, so I felt good making those applications. And I was really looking for something to replace that because my computer was pretty old, and it only ran on Windows, and Windows didn't like my laptop. Windows would just, I don't know if it had a hardware issue or what the issue was. It would just freeze up every so often for like a few seconds, and eventually it just got really annoying. When I use Linux, it would probably happen like once a day compared to multiple times a day. So I was like, you know, I'm gonna switch. So I switched over to Debian at the time, and the problem was Delphi only runs on Windows. And I was like, oh, come on. So I decided, you know, I'm just gonna find a new language. So I was looking. Python seemed like the best candidate at the time, but I was like, I don't like Python. There's still some things in Python that, you know, when applications start to grow, they cause problems.
Hey guys, I think I'm gonna call
Yeah.
it.
I think we should probably all call it a night.
Oh, okay. Sorry, I didn't mean to call it.
No. It's been about half an hour over the time.
Yeah. I was gonna say we should probably wrap things up.
Yeah.
Right, cool.
Well, thank you again for the presentation, Michael. That was wonderful.
Thank you so much
Yeah.
for listening.
And
Yeah,
the idea is really good as well. I really wish I could say that I would be able to join in, but I think I've put too much on my plate, and I really should stop putting more things on. Just like when Barry said, you know, the Dallas group, I was like, yes, I want to do it. Wait, no, just to stop taking on more things, man.
Yeah, me too. I was like, oh my god, it'd be fun to just like join
Exactly.
like, a club or something. But like, I was
That
like,
sounds
wait,
so
no, I have
exciting.
so many other commitments. I already kind of like spread myself a little bit. Then I don't think I should do that too.
Yeah, but
No
thank you guys for
worries.
the invitation. It was very, very, very tempting. But like good chocolate, sometimes you have to let it go.
Yeah.
No worries. All right, guys.
All right, everyone. Have a good
See you
night.
next time.
Bye.
Bye.
Take care, everyone. Thanks for the chat,
Right. Yep. Take care, man. Bye.
Later.
as always. All right. Have a good night.
All right. You too.
Night.